Hello everyone, today I will be talking about one of the commodity minerals, indium. Indium is considered a mineral because it has a metallic luster and a rectangular crystalline structure. It was discovered in 1863 by Ferdinand Reich and Hieronymus Richter. Indium is also a metal on the periodic table. It is number 49. So you all may be wondering, where can indium be found? Indium can be found in the Earth's crust and in the United States. The state that has the most abundant indium is Alaska. The U.S. Geological Survey stated that between the years 2015 and 2018, indium was imported from China, Canada, Republic of Korea, Taiwan, and other countries. In the right-hand corner, I created a pie chart to demonstrate how much indium would be imported into the United States. As you can see, the highest percentage of indium was imported into the U.S. from China, which was 36%. The smallest percentage of indium that was imported into the U.S. was from Taiwan, which was 7%. An example of a company that mines indium is Teck Resources Limited. They are located in Vancouver, Canada, and were established in 1910. Teck Resources Limited has many different operations and are not only limited to Canada. Teck Resources Limited stated that there are 7 in Canada, 1 in the United States, 1 in Peru, and 2 in Chile. This company was able to discover that indium was a byproduct of zinc smelting at one of the operations in Canada, which was the Trails operations. Smelting is a process that involves extracting base metals from an ore by heating or melting it. The image in the right-hand corner of the slide is what the Trails operation looked like in Canada. So, how much does indium cost? Every year, the United States Geological Survey publishes mineral commodity summaries, which explains any trends that have occurred to a specific commodity mineral. The commodity mineral I was interested in studying was indium, and in this slide you should be able to see a table that explains how the cost of indium changed from 2018 to 2019. In addition, there is a graph that represents the changes from 2018 to 2019. The first 2 rows of the table explains the price of indium in 2019. The estimated average New York dealer price of indium in 2019 was $390 per kilogram, and the average monthly price of indium in January 2019 was also $390 per kilogram. The average free market price of indium in 2019 was $210 per kilogram. The third and fourth row explains the price of indium in 2018. In 2018, the estimated average New York dealer price of indium was $380 per kilogram. The average monthly price of indium in January 2018 was $350 per kilogram, and the average free market price of indium in 2018 was $310 per kilogram. Indium has many different uses. For example, it can be used to create indium tin oxide, ITO. Indium tin oxide can be found in computer screens, solar panels, and even your cell phone. Indium can also be used as an alloy for certain materials because, according to an article by Lastly, indium has a low melting point of 156.6 degrees Celsius. An example of an alloy would be a gallium-indium tin alloy, which is also known as gallium, and it can sometimes be substituted for mercury. Another way indium can be used is as a semiconductor. Semiconductors make up roughly 9% of indium's global use. Although indium has many different uses, there are some issues with extracting indium. For example, indium is a rare mineral that has an abundance of 1 to 100 parts per million in zinc ore. In the Mineral Commodities Summary for 2020, the United States Geological Survey, USGS, discovered that the average monthly free market price of indium decreased. In January of 2019, it was sold at $232 per kilogram, and it decreased to $160 per kilogram in September of 2019. In the right-hand corner, you should be able to see a graph that I created to demonstrate the change in the average monthly free market price of indium. Another issue with extracting indium is that there is no indium in the government stockpile, which is why indium is considered a commodity mineral. So, what can we do to prevent the overconsumption of indium? We can use other commodity minerals such as antimony and hafnium. Antimony and hafnium are also metals that are on the periodic table. Lentech stated that antimony is number 51, and an article by Pedersen 2018 stated that hafnium is number 72. The commodity mineral antimony can be used to create antimony tin oxide, which can be used to help make phone screens. The commodity mineral hafnium can be used to help make alloys. In the right-hand corner, you should be able to see images of how antimony and hafnium are like indium. One thing that these minerals have in common is that they have a metallic luster. Thank you, and I hope you enjoyed learning about the commodity mineral indium. If you would like to learn more information about indium, you can watch this YouTube video. I would recommend that you start the video at 48 seconds and stop it at 2 minutes and 6 seconds.
2 rows below aluminum on the periodic table. Yet aluminum is more than 1,000,000 times more abundant in Earth's crust. As much as 75% of the world's indium production is used to make indium tin oxide, which has the remarkable property of conducting electricity while remaining completely transparent. It's a key component in LCDs and touchscreens, so you're probably looking at or through some indium right now. It's also used in solar panels and for the ball bearings in Formula One race cars. The world is planning on building a lot of solar panels and LCDs in the coming years, so we're going to need a big supply of indium, which is kind of a problem. In fact, some estimates suggest our demand for the element may begin to exceed production by 2030. Unfortunately, increasing that production is easier said than done. Indium is mined mainly as a byproduct of zinc extraction, but even then it's rare, with abundances anywhere from 1 to 100 parts per million in zinc ore. So a big increase in indium production means a glut of zinc, whether we need more of that metal or not. Instead of producing more indium, another option is to simply use less of it. Since we're not likely to give up on televisions and solar panels, that means finding an alternative. For screens, that could mean antimony, but the criticality of that element is even higher than that of indium, so not a great substitute. Manufacturers of solar panels could replace indium with graphene or carbon nanotubes, but these advanced materials are still experimental and very expensive. It's not only